Hi guys, let's start a new chapter. This new chapter is called Heights and Distance. This chapter is very closely related to the previous chapter that we just finished, trigonometrical identities and trigonometry. So let's look at how we can use trigonometry to find heights and distance between objects. Two new concepts in this. One is called angle of elevation and the other is called angle of depression. So let's look at these two things before we start our solving questions. So let's say this AB is a tower which is standing on a ground. This is my ground, and let's say you are a man standing here at point C trying to look at the top point of the tower. So the angle that your line of sight would make with the ground while viewing the top of this tower is known as angle of elevation. I repeat, if you're trying to look at the top of a tower or a building or something which is higher than you from the ground, the angle that your line of sight would make with the ground horizontal is known as angle of elevation. Now it is very obvious that I am left with a triangle ABC, which is a right angle triangle, and I will be able to use the three trigonometrical functions, which is sine, cos and tan. If I use tan, I can figure out the tower, the height of the tower, or the distance between the tower and the man. Similarly, if I use sine and cos, I can maybe figure out the length of the hypotenuse, which is the distance between the man and the top of the tower, or even the distance between man and the tower. So those are things that we can figure out. Next, let's look at angle of depression. In angle of depression, the situation is changed, which is this is still the tower. This is still AB and this is C. Now the man is standing at the top of the tower. So the man is standing here and he's trying to look at a point or a car or a moving object or another man or a sign on which is kept on the ground. So this is the ground, and the man now is at the top of the tower trying to observe something which is at a height lesser than him. So the angle which the line of sight makes with the imaginary horizontal line is known as the angle of depression. I repeat, this time the man is on the top of the tower and he's trying to look at something which is on the ground. So the angle which the line of sight makes with the imaginary horizontal is known as angle of depression. Let's look at one more thing, which is what is the relation between AD, I've just named this point AD, so AD is the imaginary horizontal, and BC, which is the ground. Yes, these are parallel lines because the imaginary horizontal makes an angle of 90 degree with the tower and the ground also makes an angle of 90 degree. So these two are co-interior angle, the sum of which is 180, which means AD is parallel to BC, which means angle DAC, which is what I'm marking in red now, is equal to the angle ACB, which I am marking in red again because these are alternate angles, which means angle of elevation will always be equal to the angle of depression. Perfect. Now let's revise the three trigonometrical ratios and then we'll solve some question. So if this is a right angle triangle, sine theta would be equal to perpendicular upon hypotenuse. This is perpendicular, this is base, and this is hypotenuse. Some people refer to the perpendicular also as opposite and the base as adjacent. So whichever way is convenient for you. Sine theta in this case would be AB upon AC. Cos theta would be equal to BC upon AC, and tan theta would be equal to opposite or perpendicular upon base, which is AB upon BC. Perfect. Let's try and solve some questions. Let's look at question number 1. Question number 1 says the height of a tree is √3 times the length of its shadow. So let's look at a rough diagram. Okay, so this is my rough diagram. This is our tree. This is the shadow that will form on the ground, and this is the angle of elevation of the sun. Where's the sun? So the sun will be somewhere here. This is our sun, and the sun ray is falling on this tree. That's why the shadow is being formed. So this is the theta that we are talking about. This is A, B, and C. common mistake which students end up doing is not marking the 90-degree sign, which is why they lose a mark. Now this sign of marking this triangle as a right angle triangle, or showing that the tree is making an angle of 90 degree with the ground, is mandatory, because all trigonometrical ratios for our case would be applicable only if it is a right angle triangle. So the height is √3 times the length of the shadow. So let length of shadow be x meter. So this is x. Therefore, height of tree is √3 times x, which is x √3 meter. So this is x √3 meter. Now that we have our basic thing clear, let's figure out which trigonometrical ratio works with if this is the angle of reference. So we're looking at a perpendicular upon base, which means we're looking at tan. So tan theta would be equal to AB upon BC. In this case, x √3 upon x, which x gets cancelled. So tan theta is equal to √3. Since tan 60 degree is equal to √3, therefore theta is equal to 60 degree, which means angle of elevation of the sun is 60 degree. Perfect. That's the question that they had. We've been able to get our solution. Good. Let's look at another question and see if we are able to solve it as easily as we were able to solve this one here. Next one, angle of elevation of top of a tower from a point on ground at a distance. Okay, so let's again draw a rough diagram. So this is my tower. Let's see, let me name this A, B and C. This would be my perpendicular, highlighting or marking that this is making an angle of 90 degree. This is the tower from a point on a ground at a distance of 160 meters. So this is the ground, and this distance between B and C is 160 meters. And this angle of elevation is given as 60 degree. Find the height of the tower. So we need to find AB, right? So let's again, which ratio? Again, it's tan, because we're looking at, for this reference point, reference angle, we have perpendicular upon base. So tan 60 degree would be equal to AB upon BC. Tan 60 degree we know is √3. In this case, AB is AB and BC is 160, which means AB would be equal to 160 √3 meter. Looking at the end of your textbook, value of √3 given is 160 and √3 given is 1.732 meter. So the AB, which is the height, let's just multiply 1732 into 16. 12, 18, 119, 42 and 143, that's 10. So this is 2, 3, 7, 1. 2, 11, 7, 7, 2. So the answer is 277.12 meter. AB is not referred to in the question, so we will have to write as per the question. Therefore, height of tower is 277.12 meter. Good. Again, a simple one. Let's look at the next question. The next question that we solve is question number 4. It says two people standing on opposite sides of a tower. Also, this time we have a slightly different question. There are two people now. So this is the tower. One person is standing on one side, the other person standing on the other side. Okay. So are they equidistant from the tower? No, that's not given. It says one angle of elevation is 30, one angle of elevation is 38. So obviously the person who's standing closer to the tower will have a higher angle of elevation, and the person who's standing further away from the tower will have slightly lesser angle of elevation. So let's say this is 30 degree and this one, which is closer, is 38 degree, marking the 90. This is basically my tower AB. This is man 1. and this is man 2. This point we'll call it as C, we'll call it as D. Let this value be X, and let this distance between B and C be Y. Perfect. Now let's look at these two separate triangles and see how we can work on this one. Good. So yeah, let's start. So let's first look at in triangle ABD. Again, I have perpendicular upon base or opposite upon adjacent, which means tan 30 degree is equal to AB upon BD. In this case, tan 30 we know is 1 upon root 3. So 1 upon root 3 is equal to AB, which is height of the tower is given. Yes, the height of the tower is 50 meter. Otherwise, how would we calculate if we have both the variable? So then AB is given, which is 50, and the distance between B and D, which is X, we don't know. So X will be equal to 50 root 3 meter. Again, let's calculate and see what's the answer. This is 1732 into 5. 5 into 2, 10, 15 and 1, 16, 35 and 1, 36, that's 8. Therefore, X is equal to BD is equal to 86.60 meter. So we figured out this distance. Now we need to figure out the distance of B and C. So let's look at the second triangle. In a right triangle ABC. Again, let's look at tan. So tan 38 degree would be equal to AB upon BC. Tan 38, let me refer to the log table. Tan 38 as per the log table is 0.7813, which will be equal to AB, which is 50, upon BC, which is Y, which we need to calculate, which means Y will be equal to 50 upon 0.7813. Wow, that's a big calculation. So if you're getting worried about this calculation, well, even I'm worried about this calculation. It's a lengthy process of dividing by a 4-digit decimal number. Let's see if we can do away with this long decimal division. I personally prefer multiplication to division, decimal multiplication also to decimal division, because dividing by 4-digit decimal is slightly more difficult for me and time consuming. More than difficult, it's far more time consuming. So now let's revise certain things that we've learned. The sum of all three angles in a triangle is 180 degree, which means if this is 90 degree, because this is a right angle triangle, this is 38 degree. So what's the measure of this angle A? So let's just write that. In triangle ABC, 90 degree plus 38 degree plus angle BAC is equal to 180 degree. This is angle sum property. Therefore, angle BAC would be equal to 180 minus 128, which is equal to 52 degree. So I now know that this angle is 52 degree. Now let me try and see, because if I take tan of 52 degree, what I will get is the numerator will be y, which will make my life simpler. Maybe it will. Let's look at this. So tan 52 degree, this time my angle of reference is this 52 degree. So this would be equal to BC upon AB. Tan 52 degree as per the logbook in your textbook is equal to 1.2799, which is equal to BC. BC is Y upon AB, which is 50, which means now I have a multiplication which is for me far easier, far faster than decimal division. So Y is equal to 1.2799 into 50. Let's just do this calculation. 12799 into 5. 5 9s are 45. 45 and 4, 49. 35 and 4, 39. 10 and 3, 13. 5 and 5 and 6. So that's 63,995, which means 4 decimal, which means two more decimals. So this is 63.995 meter. Right. There were 4, so 1, 2, 3, 4, which was 6.3, but I have a 0 here, so it will become 63. Right, so 63.995. What do we need to calculate? Find the distance between them. So which means the distance between them is y plus x. Therefore, distance between them is equal to, what was the first value? 86.60. 86.60 plus 63.995, which is equal to 150. Let's just do the calculation. 63.995 and 86.60. That'll be 599 plus 6, 15. That'll be 10. That's 50. 150.595 meter. That's my final answer. I hope you realized that I have been able to avoid long decimal division by changing my angle of reference. Earlier, angle C was my angle of reference. I calculated the angle A using the angle sum property, and my angle of reference then became angle A, and here I had to do multiplication rather than division, which to me is easier. Thank you so much. Take care. Be safe. Homework question for you today is question number 3. Thank you. I'll see you with the next video. Bye bye.